Wrapping up cell convention. When we first started looking at electrochemistry, the first thing I told you needed to do was to know whether a chemical reaction actually could be an electrochemical cell. And that's why we had to learn about oxidation numbers, and then from that we learned about change in oxidation numbers, and we learned whether oxidation and reduction took place. Then once we knew whether oxidation and reduction took place, we were able to move forward to putting it into practical play here as we started looking at cell convention. And at that point we realized that you always have one cell, half cell, which is oxidation, and one that's reduction. I need to give some names to the terminology associated with it, to the signs associated with it. And that's where we developed all these ideas about an anode and a cathode, and whether the signs are plus and minus, and the fact that we have a salt bridge, and the fact that we have electron flow. Keep this in your mind, because from now on, when I show you a battery, you should immediately begin labeling all the parts of that battery and appreciating what their function is and allowing us to be able to create a completed circuit. The most important thing in all of this, though, is that you need to be able to look at this number sitting right here, that voltage. That voltage right there is this thing that we looked at way back at the beginning of the lecture. What was that? That was the idea that in the same way that we talked about delta G being associated with the free energy, and the larger delta G was the farther something could fall down the hill, now we're seeing that delta G is related to the electrochemical potential. And the size of that hill is going to be proportional to the size of the free energy. And we'll learn in just a bit about the number of those electrons that sit at the top of the hill, and the fact that the number of the electrons sitting at the top of the hill, which is equal to the current, can be multiplied by that electrochemical potential. Because guess what electrochemical potential times the current is? That's the amount of work that's being done by this system. That very same work we talked about when we were doing expansion work, but now it's going to be work that's electrical work.